Solving rational equations. These are rational because x is both in the numerator and the denominator. There are two problems here. I can't fit them both on one page. However, this one is slightly simpler, and the one in the next on the next page in the next recording is more complex if you'd like to look there. All right, first things first, we need to find the LCD, the least common denominator, or it's really just the least common multiple. In this case, we need to take a look at all three of our denominators, which are 6x, a 1, remember this is just 1 over 1, and x. The least thing that all of those things, 6x, 1, and x, can all be multiplied to is 6x. I can multiply 6x by just 1 and get 6x. 1 doesn't affect anything, and the x over here can be multiplied by 6 in order to get 6x. Okay, now I need to multiply all three fractions by 6x, or 6x over 1. I don't really like to write the over 1. Your book does have over 1 in the example, so it's up to you if you want to put it or not. It doesn't really matter. All right, we're multiplying all of them by 6x. In this first case, it's going to cancel out. 6x over 6x cancels out. We're left with just x plus 2. In the next one, nothing cancels out, so 6x times 1 is 6x. Over here, it's interesting. It's a partial cancellation. Just the x cancels. Just the x. So we have a 6 times the quantity x minus 7. And now we can just solve algebraically. I'm going to combine the like terms over here and distribute on the right. And from here, it's a basic couple-step algebra problem. If we subtract 6x from both sides, we'll be left with 1x over here. And subtracting 2 from both sides will yield our solution of negative 44. Now, in problems like this, when x is in the denominator at the beginning, like all these rational ones, you have to make sure before you just circle your answer like I'm doing wrongly right now, that it works, meaning it's not a restricted value. So if you recall, a restricted value will make our denominator equal 0. It won't work. If we plug in, and you should just be able to see this, but if we plug in negative 44 into the denominator here, we'll have 6 times negative 44, which is something, but it's not 0. We can't plug it into the denominator here. There's no x in a denominator. And here x is just the denominator. So plugging in, we just get negative 44 in our denominator. So none of them will give us 0. So we're good. Negative 44 is our solution. Okay, slightly more complicated looking problem. In this case, we have some more complex denominators that all need to be factored. So look back at factoring if you need to review. All right, let's rewrite some of these. This first guy is going to factor into x minus 4 and x plus 2. The second one is a difference of squares. So that's going to factor into x plus 4 and x minus 4. And the very last one, two numbers that multiply to 8 that add to 6 are both positive 4 and a positive 2. All right. Our LCD here, the cool part about when you get all these guys in parentheses here, all these different factors, is that your LCD is just each one of those factors written only one time. So we really only have three different ones. We have an x minus 4, we have an x plus 4, and looks like we have an x plus 2. Cool. So that's not too crazy. All right, we're going to multiply every single numerator by the entire LCD. So I'm going to write it across like by the numerator here, because that's really what multiplying by a fraction means. It means putting whatever you're multiplying by in the numerator. The goal is to get everything in your denominator to cancel out. It looks like that's going to happen. The x plus 2's cancel out, so do the x minus 4's. Now what you're left with, and don't forget, you still have to write what you originally had in your numerator. In this case, it's a 4. We also have to write the part of the LCD that didn't cancel. So we have two things that we have to make sure we write down. We have the 4, and in parentheses we have the x plus 4. Okay, let's do that again for our second fraction. And in this case, the two factors that end up canceling were the ones with the 4's. All right, and we're left with that minus sign. That's important. Don't forget it. A 1. No, you don't have to write the 1, but whatever. All right, and lastly, we're going to do it, and let's try to just do this one in our heads. Let's look at which two are going to cancel. It looks like the x plus 4, those will cancel out, and the x plus 2's will cancel out. So what will we still be left with in the numerator? Of course, our 2 and our x minus 4. So I'm going to just cancel that from up here. There we go. And some of you can just see that in your head after a while. The factoring's not going to be too crazy, so you're definitely able to do some of it in your head. All right, from here I'm just distributing and really solving. The hard part's done. Now it's basic algebra. So I did some distributive property. Now I want to clean it up a little bit by combining some like terms. Whoops. Let's see. Didn't mean to put 5x there. I got 4x minus x. See, teachers make mistakes too. All right, 2x minus 8. Okay, subtracting 2x from both sides, let's do that in our heads. We'll be left with 1x over here. And subtracting 14 from both sides, negative 8 minus another 14 is a negative 22. Let's see, is negative 22 a viable solution, meaning it does not make our denominator 0? Let's check it out. The cool thing is we don't have to look back at these more complex looking denominators. We can look at our factored form. And so long as we don't make any one of these factors 0, then we're good. It looks like the only restrictions here would be positive 4, negative 4, and negative 2. And that's not negative 22, so there's our solution.